It's time for another meeting of...
The Science Alliance!
Hi, I'm Rex Hagen, and welcome to this meeting of the Science Alliance.
And I'm Judy Halliday. From the 5 clues we gave you at the beginning of the program, you might have guessed that we're going to be talking about all the things around us that we call matter.
And our first question comes from our announcer, Bryant.
Thanks, Rex. Actually, our first question is a riddle. What does Rex have in common with grape juice and the air in a tire?
The answer to Brian's riddle has something to do with the subject of our program, matter.
Matter can be a liquid, like water, milk, or grape juice.
Matter can be a gas, like the helium in a balloon, the air all around us, or the air in a tire.
Or matter can be a solid, like buildings and trees, rocks and seagulls, or like you and me.
Solids, liquids, and gases are called states of matter. So the answer to Brian's riddle is that Rex, grape juice, and the air in a tire are all matter.
That's right, because matter can be found in one of 3 states: the solid state, the liquid state, or the gas state. Kim asks our second question. She wants to know, can you measure matter?
Mass is the amount of matter in something. So anything that is matter should have mass. There is a way to measure the mass of something with a balance. This is a brick measured at 2,700 grams. If I take the brick and place it on this side of the balance, it goes down. How much mass do you have to add to your side to make the sides balance again?
2,700 grams.
Try it. Do the sides balance?
Yes.
Right. We've shown you one way to measure mass. Now let's go to Rex. He'll measure the mass of a gas.
Right, Judy. We said that the air in a tire was matter, so it should have mass. I'll use a balance, too. Now, right now, both these tires are empty, and they balance each other. But let's see what happens when I add air to the tire on this side. The tires are no longer in balance. The tire on this side has more mass than the tire on that side. So we found out that a gas, like the air in this tire, has mass.
Now let's measure matter that's in the liquid state, like this grape juice. When I pour the grape juice into the container on this side of the balance, it goes down. Tanya, add an equal amount of mass to your side. 20 grams, 40 grams, 60 grams, 80 grams. The grape juice has a mass of 80 grams. We've shown you that matter in the liquid state has mass. We also said that Rex was matter, so he should have mass. Rex, how about it?
All right, Judy. I'm going to use the help of 2 people. Now, on this balance, I have Mike on this side and Mike's dad, Bram. As you can see from the balance, Bram has more mass than his son. In fact, Bram's mass is 95 kilograms. Mike has a mass of only 25 kilograms. Let's see what happens when I get on the balance. The scales are now in balance. Can you figure out what my mass is? 95 kilograms minus 25 kilograms equals 70 kilograms. So I have a mass of 70 kilograms.
So now we've shown you how to measure the mass of matter, whether it's in the gas state, like the air in a tire, whether it's in the liquid state, like grape juice, or whether it's in the solid state, like Rex.
John wants to know, is there anything else that's the same about all matter?
Scientists tell us that all matter takes up space. Right now, there is no liquid in this container. Now, it has some liquid in it. The liquid, grape juice, takes up space in the container. The container has been measured to hold 500 milliliters of liquid. That means the grape juice takes up 500 milliliters of space. What will happen if I pour in more? No wonder. Nothing more can fit into this space.
Excuse me, Judy. Isn't there a proper scientific term for taking up space?
That's right, Bryant. The proper term is volume.
Thank you. That's my first word. And that means it's time for Bryant's Giants of Science. Archimedes was a scientist who lived in Greece a long time ago. The king knew that whenever he had a problem no one else could solve, Archimedes usually came up with a solution. One day, the king asked Archimedes to figure out the mass and volume of his new golden crown. It was easy for Archimedes to find its mass with a balance, and he could find the volume of something by measuring its height, length, and width. But the crown was very intricate and impossible to measure accurately. How could he find its volume without harming it? One day, after he had spent a long time trying to find a way to solve this puzzle, Archimedes was getting into his bath when he noticed that the water flowed over the side of the tub. That's not surprising, he thought. The water in the tub and my body can't be in the same place at the same time. Eureka! He shouted as he got out of the tub and ran into the street. I found it! I can find out the volume of something by finding out how much water it will displace. And indeed, he had found out a way to find the volume of something in a new way, without having to do any difficult mathematics. And, of course, he was able to tell the king the volume of his crown. Bryant salutes Archimedes, the man who found an easier way to find the volume of something, and truly a great giant of science.
Thanks, Bryant. I'm going to use Archimedes' method to show you that the air in a tire has volume. Right now, I have water and an empty tire in this tank, and the water is just about overflowing. Now, what will happen when I add air to this empty tire? Let's see. The air and the water cannot take up the same space. It overflows.
So Rex has shown you that the air in a tire takes up space. It has volume. Now it's his turn. All right, Rex, it's your turn.
My turn for what?
Let's see if you have volume.
Well, fortunately, I've come prepared. Let's see what happens when I get into this tank. Well, it overflowed, so I must have volume.
So now you've seen a way to find the volume of matter when it's in the gas state, like the air in a tire, when it's in a liquid state, like grape juice, or when it's in the solid state, like Rex. Most things you can see, and many things you can't see, are matter. All matter has mass, and all matter has volume.
Here's a good question from Michael. He wants to know, can matter be changed from one state to another?
I have two ice pops, one in the solid state and one in the liquid state. How did the ice pop change from a solid to a liquid?
They melted.
Right. And what's happening to the ice cubes you've been holding?
They're melting.
Right. Whenever matter changes from the solid state to the liquid state, we say it's melting. It's still the same matter, it's just in a different state. To change matter from a solid to a liquid, we need heat. The heat around us is changing the ice cubes from a solid to a liquid. Other solids can melt too. The heat from a flame of a candle changes the solid wax into liquid wax. You always have to add heat to change a solid to a liquid. Ice cream melts on a warm day. Icicles melt when it's warm. And the snow you collect outside will melt once you bring it inside. Some solids need large amounts of heat before they will melt. In a steel plant, the furnaces raise the temperature of the iron to over 1,600 degrees Celsius before the iron melts. So as you can see, a solid can be changed to a liquid by adding heat. This is called melting.
Carrie is going to help me show you another change of state. This is a liquid called alcohol. Now watch what happens when I dab some alcohol on Carrie's wrist. Now it seems to be disappearing. We say that it's evaporating. It's changing from the liquid state to the gas state. We can't see it, but I can still smell it. Let's try it on everybody else, okay? Just put a little bit here. Then I'm going to ask you a question about this. Okay, here's the question. Here's the question. What does your wrist feel like?
Cold. Tickly.
Feels cool. All right, here's the reason. The heat needed to evaporate the alcohol comes from your wrist.
When you boil water, some of the water changes into a gas called water vapor and seems to disappear into the air. So as you can see, a liquid can be changed into a gas by adding heat. This is called evaporation.
Rosemary wants to know, are there other changes of state?
We've shown you two changes of state, melting and evaporation, that take place by adding heat. Here is a change of state that takes place when you take away heat. Right now, the water in the kettle is boiling, and some of the water, a liquid, is changing to a water vapor, a gas. Kenny has a piece of glass in his hand. Is it hot? No. Okay, what I'd like you to do, Kenny, is take the glass and place it over the spout of the kettle, where some of the water vapor is escaping. Very good. Do you see anything forming on the glass?
Water.
Right. Some of the water vapor is changing into water drops. Or we say it's condensing. When you take away enough heat from a gas, it can become a liquid. You might have seen condensation on the outside of a cold glass, or in the morning on cold blades of grass as dew, or falling from the clouds in the form of rain. So as you can see, a gas can change to a liquid by taking away heat. This is called condensation.
All right, Evelyn, pour some water on the pie plate. Now, we're doing an experiment with something that's even colder than an ice cube. This is dry ice, and it's minus 56 degrees Celsius. The dry ice takes the heat from the water and turns the water into ice. Evelyn, what do we call this change of state?
Freezing.
Freezing. You can change a liquid into a solid by taking away enough heat, and we call this freezing. How many examples of freezing can you think of?
Can you think of other examples of changes of state? Can a gas change to a solid?
Can a solid change to a gas? There are many ways that you can find out answers to our questions, and there are many more things that you might like to find out about matter.
Before we see you at our next meeting of the Science Alliance, find out all you can by experimenting, reading books, and talking to people. Bye.
Bye-bye.